So, good morning. I'm Ted Briscoe from the Alta Institute. What I'm going to do today is talk a little bit about the program behind Write and Improve, and also tell you a little bit about how it works, and then go on and show you how the system has developed over time. It's great to be here because Write and Improve was launched as a beta system in the cloud. It went live in 2014 at an IA TEFL as well. So it's kind of nice for me to be back here and to be able to kind of review all the things we've done since. So what's the Alta Institute? Alta is just an acronym for Automated Language Teaching and Assessment. That's not really quite what we're trying to do. We're not trying to automate teaching and replace all teachers. The partners are various academics in the university who work in the language sciences, like myself. I'm a computational linguist and a machine learning person, and people in Cambridge English, which is meant to include both CUP and Cambridge Assessment, who work on English as a further language. And the basic aim is to develop new educational technology in the area of language learning and assessment. So we're not trying to replicate what is already out there, we're trying to move things forward. And Elite, English Language Tutoring, is a company, it's a joint venture which was set up to actually deploy any resulting technology that comes out of Alta. And the first thing and only thing at the moment which we're deploying is in fact Write and Improve. So what's the sort of motivation, the broad motivation behind all this? Well, there's predicted to be 2 billion people trying to learn English as a further language by 2050. But you know, you might be forgiven for thinking there are too many English teachers as you've been fighting to get lunch at IA TEFL, but in fact there's not nearly enough English teachers out there to satisfy that demand. So educational technology is a potential way of increasing productivity in a very broadest sense, putting people in touch with the right people when they're not in the right country, etc., etc. So that's really what we're interested in, trying to satisfy that demand. The university's motto is make society better, so we're trying to make society better by teaching everybody English more effectively. Okay, so what's out there in terms of technology? There's actually been a huge amount of investment in educational technology over the last decade. There's massive open online courseware, there's adaptive learning management systems, there's interactive online tutoring things, you know, apps and so on and so forth. All of this stuff costs a great deal of money to develop. Some of it's been developed in the language learning area, others, you know, the stuff that's really headline tends to be more in the sciences. So one of the sort of headline courses which has really worked was a course on machine learning, which was spun out of Stanford and eventually caused the launch of Coursera, which is a very well-funded company out there. Why did this one work and say some of the others don't seem to have had much impact at all? I think the basic thing about teaching people something like machine learning or computer science in a MOOC context is you can give people very effective feedback exactly on what they're meant to be learning. So essentially how these MOOCs work is you have to write a program that takes an input and produces an output, and the system knows what the output should look like. And that program can take a variety of forms, and they do things to check for plagiarism, because if two programs that are submitted are pretty much identical, chances are that one of them wasn't written, it was just copied. But crucially, that's really what you're trying to teach people, how to write programs. So they get excellent feedback on what they're trying to learn. It's much harder with language to give people excellent feedback on what they're trying to learn. If you look at Duolingo, which is an extremely well-engineered, very well-designed product, essentially it's a drill and kill application which applies the closed test and close variants in all sorts of ways. So I've just put out one closed test here. Can we see gap, the Earth is a globe? And your job is to guess what the right word to go in there is. And this particular one, the answer was that, and the distractors were if, where, whether, and when. But if you actually think about that sentence, there isn't really one right answer. And that's the problem with language. There isn't really one right answer. So closed tests don't really work very well. So the question for us is, can we give good, reliable, automated feedback that really does help people learn language, where the test is not a very imperfect proxy for what we mean by learning a language? Okay, so what we're going to try to do is build a system. What we have done is try to build a system which combines a bit of summative feedback. Are you at a certain CFR level? Are you getting a score on an exam like IELTS or the FCE, which would mean that you would pass? And combines that with some formative feedback. What sort of mistakes have you made and how might you improve on them? And this is quite challenging because we need to be able to reproduce the kind of grades that a human examiner would assign effectively and accurately. And we need to ideally give pretty detailed feedback, quite specific feedback on bits of writing. And we'd like, the scores to correlate well with human examiners and the feedback to look similar to what a human teacher would provide. So these are quite challenging goals. And if we could get this right, of course, it has many applications and some obvious learning advantages. I'm really going to focus on the sort of tutoring stuff today, but typically if somebody does a writing assignment, they don't get feedback before they're already doing their next writing assignment. Using this system, you get almost instant feedback. So it keeps you going, it encourages you to try alternatives. And obviously, most teachers are rather overloaded. They usually have class sizes of 40 or so. So giving individual feedback and giving incremental individual feedback in a timely fashion is basically impossible. So the machine can do something there where the feedback may not be quite as good as what an individual would give, but it's a good supplement because it's doing it very quickly and so on. So how do we build this system? Well, we use data-driven machine learning techniques. And our initial starting point was something called the Cambridge Learner Corpus, which has been developed over the last 20-something years as a joint project between CUP and Cambridge Assessment. And what that has is essentially text written in exams with grades and also error coding. Now, we've actually been, as I said, running Write and Improve for quite a long time. So although this was our starting point, we now also have a great deal of data that's come in through Write and Improve itself. Currently, Write and Improve has about 1,000 submissions a day. So that's a lot of data. And we have a team who work in Elite who do error coding on that material. In fact, the current version of Write and Improve, all the scoring engines are just based on data that's come in through Write and Improve and which we've annotated. So we use this as what we call annotated training data for supervised machine learning. And just to give you a concrete example of what this looks like, here's some error coding. The stuff in green is correct, the stuff in red is incorrect. And so we would have this and we'd have a score, which I haven't shown for this bit of text or probably a slightly longer bit. And that's the annotation that we use to drive our systems. Now, our systems need features of the text, and all the text is just a string of characters. That's not really enough to do this task well. So what we do is we apply computational linguistics tools like parsers, which are sort of generic tools that you can apply to any text. So this is a parse of "then a thought occurred to me," and it's done a bunch of different things. It's reduced the words to their sort of lemma forms, their dictionary forms. It's tagged them with a part of speech in a coding scheme that doesn't matter much, but you can sort of see that, say, occurred is tagged as a past form of a verb, and it's made up of occur plus ed. Then it's structured the sentence into some phrases and given them some labels, which again don't matter too much, but say V1 VPP just means this is a verb phrase containing a prepositional phrase. Now let's look at an error. This is a sentence from the CLC. So what the learner actually wrote was "then some though occurred to I," and they misspelled occurred. They only had one R. So when you look at that tree, you can see instantly that the shape of that tree is very different from that one. And if you also look at some of the labels, up the top it says tfrag, which means it hasn't been the system hasn't been able to find a valid parse for this sentence. Also has a bunch of rules that say -r, which means they're rare, unusual rules that don't apply very often. So this becomes an expanded kind of version of the text, which gives us various features which are cues to what might have got wrong on the quality of the text. And basically everything that comes into Write and Improve is parsed in this way. And then what we want to do is we want to use these features to provide the summative and formative feedback. And the way we do that is we identify features that are very discriminative of a particular score or very strong cues for a particular kind of error. So I'm going to concentrate first of all just on the scoring side of things and explain that in some detail, but what I explain for this really generalizes to the other tasks as well that we perform in the system. So how do we score? Well, let's say we have a scoring scheme which is just an ordinal scale like 1, 2, 3, 4. What we build is a system that looks at the new text and says, is this more like a 1 or a 2? If it's more like a 2, it then asks if it's more like a 2 or a 3, and when it finds the right level, that will be the prediction it pushes out. How do we build this system? Well, we pass in scored text. We apply some feature extraction algorithms to the text. So if, for example, we estimate the number of errors in the text, we get the length of the text, we get n-grams of part of speech, that means sequences of part of speech labels, sequences of lemmas, sequences of the actual words that were typed, we get the parsed trees, we break those down in various ways, and so on and so forth. And each of those feature types has many, many instances. And the task of the system at training time is to weight those instances according to their discriminatory value and how associated they are with a particular score. And when you've trained the system, you then apply it to text that doesn't have a label, and it spits out a label, as in a score. So what sorts of features do we use? Well, I've just said word sequences, part of speech sequences, grammatical constructions, so they're generalizations over lumps of text. And then things like there's a kind of readability or complexity estimate, which is some ratio of sentence length and things like word length. And we also have this automatic error estimate, which is based on a very large language model of good native English. So what happens with the system? Well, what we do is lots of experiments to find out how useful these feature types are. So this is correlation with human examiners' scores for text. Now the upper bound here isn't 1, so correlation is something that goes from 0, no correlation, to 1, perfect correlation. But if you compare two examiners marking a script, even good examiners, senior people who work for Cambridge Assessment and train other examiners, you're going to get a correlation of around 0.8 because this is not an absolute task, right? It's not like marking maths or checking if a computer program computes the right function or not. So as we add in these features of these different types, we get closer and closer to this upper bound, but we're not quite at it with this particular model. This is from a fairly early experiment with FCE scripts. Well, what does this actually mean in concrete terms? Well, this is what it means. Here's 4 examiners in the system. You tell me which one is the system. Anybody got any guesses? Which one is the system rather than the examiner? Pretty hard to tell, right? So you're correlating almost as well as 4 senior examiners correlate. The rates are 1 to 4 are the senior examiners, 0 is the system. So what that means is if you were to look at the output of the system trained on any one of these exams, you're really going to find it very hard to tell the difference between the scores assigned by an examiner and by the system. So what sort of features does it extract? Well, for FCE, here's some of the top ranking features. These are feature instances of those types. There are hundreds of thousands of these, and in any one script, only a few will be exemplified. The weights, where they're positive, mean that you're going to get a higher score, and where they're negative, it means you're going to get a lower score. And you can see here that the very highest one on this list, actually the very highest one I don't show, it's the error rate. But the second highest one is, do you use adjectival or adverbial phrases? And it's really looking to see if you're using more elaborated language. The second one is, are you producing lots of stuff which is ungrammatical? And that's negatively correlated. And actually, if you read the marking criteria for FCE, it talks a lot about things like modality. So then it's not too surprising that you see words like necessary and probably cropping up as really quite discriminative features for a good essay at FCE. This is FCE from over 10 years ago, so things might have changed a bit since then. Then you see things like these part-of-speech sequences, and sometimes they're indicative of ungrammatical stuff, and sometimes they're indicative of slightly more elaborated language and so on. So you can get a sort of intuitive sense of what the system's doing, but what I want to emphasize here is that there's a really, really long list of these things, and to go through them all and understand them all would be a truly Sisyphean task. So what the machine learning is doing for you is finding all these instances that are useful. We're not really making very many assumptions about what's useful or not. We haven't built into this that whether something's grammatical or not matters. It's worked that out for itself. Okay, so we used to display this sort of thing like this. We used to have a sliding scale going from red to green, and we used to give you something like a CFR level indicator. Here's another one which is better. What you can see is we've shown progress because we showed previous and next score. This was just based on putting these two things in. So somebody miraculously went from being A2 or something to C1, which clearly you wouldn't do in real life, but that's just me plugging in text from the CLC to show what the system does. So this is a genuine C1 text, or close to, I forget exactly. Okay, so that's the scoring, that's the summative feedback. What do we do for detection and correction? Well, we want to be careful that we don't tell people things are wrong when they're right, because that's known to slow down learning rate much more badly than missing things that are wrong. So we have a set of rules that we derive from the corpus that not only detect an error, but also suggest potential corrections for it. And we base those only on things that are really clearly errors in the CLC. So we have to see things recurring multiple times as errors before we actually add a rule of that kind. We also use a dictionary which captures a lot of word form errors, things like occurred with only one R and so on. And we also use machine learning again, because machine learning will generalize a bit from our database. But we mostly use machine learning just to detect errors, because machine learning generalizes just too unreliably to offer suggestions. And the typical sort of levels of coverage we get are for only making 10% errors, we only find 10% of the things that need to be marked as an error. And if you want 20%, then you're going to be making more like 20% errors, telling people things are wrong when they're right. So this is actually a very hard task. You need to know what somebody's trying to say. Here's a flavor of what the rules would look like. These are all extracted from the CLC or subsequent data that we've error coded. They tell you things like he want to is wrong, it should be want. So in the context he and to, that form of want is wrong. So they're very simple, very concrete rules like this that don't really generalize much at all. So we have a lot of this data. We have many, many corrections of this kind over probably something like 50 million words of data. But even so, we don't have anything like enough coverage. So one of the hopes with Write and Improve is that we will one day get enough data that we really are getting there. So what does the word level classifier look like? Well, I just put this up. I can't explain all of this, but the only reason I put it up is because it's exactly the same sort of deep learning paradigm that was used by DeepMind to beat the guy at Go recently, in which people are going wild in the press telling you is going to take over the world and so on. It's, when we apply it to this stuff, it's mundane enough that I think you can see it won't be taking over the world. What this is a bidirectional LSTM, which means that it goes through a sentence from left to right and right to left. It has an encoding of all the words in the sentence, which is a continuous vector of numbers and which represents the context in which words occur, and therefore is like a word similarity function. And we combine those, we combine those encodings sequentially And we also combine the left to right encodings at the point where we're looking at the current word. So if you're looking at word 2, when you pass this information up through the top, up to the very top, what that P label thing is doing is just saying, is this errorful or not? And actually it's saying, is it errorful because it's a wrong substitution for another word, or is it errorful because something is omitted before it, or is it errorful because it's added and not wanted? And that's all that this thing does. How does that actually play out? Well, it means that you can highlight something like live, which should be lifestyle, and say this is wrong, but you don't actually offer a correction. And you can also say, I have bad back, something missing in front of it. And just to give you an idea of how much progress we've made on this, the original 2014 system had an F0.5 score of 49%, which meant it was actually making the text slightly worse rather than better. No, that's not true. It's not quite that bad, but it was really doing very little improvement overall. And now we've got up to 56.4% with this cutting-edge deep learning system. So you can see, and there's been a lot of work on this, so you can see this is a very, very slow progress towards a system that really would be as good as you and I at spotting errors. Okay, so the other final thing we do with error, with sort of indicating regions of error, is that we spot sentences that look very problematic. So in that previous system, we're going right down to a particular word in a very specific location. Sometimes we're unable to do that, but we can say there are some problems with this sentence. And we don't have any training data for that, but what we can do is estimate the errorfulness of a sentence from the overall score from a piece of text, and also our estimate of the error rate within that piece of text, which is a sentence. And again, using this green-red coding, what you have at the top is some corrected CLC sentences, and at the bottom you have their incorrect variants. And what you see is that this system is coloring redder the things that have errors in, and coloring greener the counterparts that don't have errors in. And so it's ranking correct and incorrect variants of a sentence appropriately. So we used to show all this like this. We used to put the score up the top and color sentences, and if we could find anything to highlight that was wrong, we would put a red box around it. When, around about the time the first version came out, a journalist put Churchill's "We'll fight them on the beaches" speech through ETS's criterion system, and the criterion came back and said this is absolute rubbish and it's got far too much repetition in it and this guy ought to fail, or whatever. This was a nice little trick because, of course, we're meant to think that this speech was, it galvanized the whole nation into action, so it must be brilliant. What he actually put through was a Wikipedia transcription of the speech with some fairly dodgy punctuation, which is called, and it is a speech, it's not written. It also contains many words that you would never find in the training data for a system like this, because typically you're not asked to write about the Gestapo and Nazis in the sort of prompts that you get. And these systems are only as good as the data they're trained on. So I shoved it through ours just to see what would happen back then, and of course it's coloring everything red and it's given a low score. By last year, we were no longer coloring everything red, although we still thought grounds was a problem. And we were giving at least a slightly higher score, but you can see that it's still not really very clear that this is perfectly competent, although slightly archaic English. So the reason I put this up is because there's a limit to this technology. It's not as clever as a person. It can't back off and say, this is an outlier kind of script. It's only as good as what it is trained on. But if it's trained on a lot of typical learner English, then it should be good with a typical learner. And that's the point of it. So in a sense, it was a misguided thing to do, although it was a very clever way of creating a negative impression of the technology. Okay, so Write and Improve has moved on, and it's about to become a freemium product with some premium features. Because it's costing us a lot of money to develop this, and at some point, if we're going to keep going, we're going to need to try to cover the costs. So what's in it at the moment? Well, a lot of this stuff is just in the free part, which will always remain free. There's much better scoring and modestly better sort of formative feedback. There's a much improved user interface based on all the feedback we've had from learners and teachers. There's gamification to try to make things a bit more positive, because a lot of what we're doing is saying, you got this wrong, you got that wrong, and that can be a bit demotivating. So we also award points now for effort. There's workbooks that teachers can create with prompts of their own in, and they can advertise those to classes so that they can quickly and easily assign the writing task to people. And in class view, we have a lot of student profiling. So you can get in very quickly, drill down, and see what students are doing. And then finally, we're going to give some exam-specific feedback. Okay, so let me just jump to the system and just give you a very quick demo. So I'm in Write and Improve as myself. And here is a task from IELTS, and this is task 1, so we've got a table here. You can actually upload more complex prompts with things like graphs and tables. And if I go back to this workbook, I actually put some text in this one. It's just entirely silly text, and I got a score of 6 for this bit of text. Predominantly, I think, because the bit of text wasn't long enough for the task, otherwise it might have got a 7. So you can see that here we're scoring on the IELTS 0 to 9 scale rather than on the CEFR scale. So now let's go back and look at some real text that I put in. Here's one where I put in some text here which is taken from Lang 8, the language exchange website, where you can upload some writing in a language that you're learning, and other people will give you feedback on that writing. So it's just a nice source of genuine text. And this person is writing at about level A2, according to the system, and you can see that there's lots and lots of errors here. And if I click on this, it tells me maybe this is an extra word that you don't need. So it's giving some specific hints about how to improve things, although not perfect hints. They're saying that the form of this word A might be wrong. It should perhaps be an, which is pretty much telling you the answer there. Let's look at the next one. It's saying a co-worker ask, is this the correct word? It doesn't look right. So we haven't been able to actually figure out quite what's wrong there, but we know there's something wrong, and so on. So I can look at this, and I can go to my text over here, which looks, yeah, okay. So I could, for example, fix this. I might think, well, I would need to say I have succeeded reduce amount of coffee. Maybe I would then think that I might want to make that ing or something like that, or maybe I wouldn't. And I could go on like this, and then when I'm happy, or I run out of ideas, I can check again. And the system quite quickly will run that through again and come up with some more advice for me. And there we go. And now the first sentence is still hatched, so it still thinks there's something wrong, but it no longer has any specific advice for me. There isn't a single sentence in here that it thinks is perfect, so I've still got a lot of work to do. But it gives me a little piece of positive advice at the top. It says, keep trying, reading your writing again, and study the feedback. Make changes and click check again. So it's encouraging you just to keep trying stuff. Actually, and me too is all right. That's the only bit of this that it thinks is a perfect sentence at the moment. And you can see that the interface has changed quite a lot. We're presenting stuff in a rather different kind of way, which seems to be much clearer for people now. Okay. Down here, you get progress. So the progress is a bit funny here because I'm not progressing continuously and getting better because I'm just playing around with the thing. And if I'm the teacher, I can go to this sort of view, and this gives me an idea of who's done what. So what we're seeing here is a graph of activity by all the, and this is real data, by the way, which we're using with permission for somebody who gets their students using the system a lot. And you can quickly drill down in this system to get different views. So here you have a kind of graph view, and if you want to highlight a particular student, you can highlight the student. If you want to see how they're doing relative to another one, you can just link over them. There, something's gone really wrong because instead of progressing continuously, they've dropped off. So I might want to actually look at that and say, okay, what went wrong there? And if the system was responding, and I could select a particular thing, then I should be able to do that. So this is a heat map. What this is telling you is for each student what sort of scores they're getting as a colour, and if you see it going from dark blue to light blue, it means they're getting better. But let's say I'm particularly interested in that one. I click on it, and then I go down, and here we have that particular text that they entered, what's wrong with it, marked up, and we can see how long they took, how many goes they've taken, and so on. So you have a lot of stuff that you can use to quickly explore what your students are doing, and that's going to be available very soon. And I just want to put up now the slide which tells you how to get access to all of this, if I can close things quickly and finish the session. If anybody has any questions, quick questions, please do ask now.
I noticed examples of scoring using the CEFL scale and the IELTS scale.
Yeah?
You said there were specific IELTS tasks in there. I know you can start your own workbook.
Yes, so
does that mean you can choose to have the work marked on the IELTS score?
Yes, yes, exactly. Absolutely, yes.
How you want it marked?
Yeah, yeah. And at the moment, or soon, those will be the first options, but the plan is to put in Cambridge first and maybe a business exam next, yeah. Yeah?
I've just tried to get in, it's asking me for an invitation code. Is that it?
Yep. So you get free access to the premium features with this for a few months, so write this down, yeah?
How long you reckon will a system like this be introduced for general purposes?
Well, it's been out there forever. You've been free to use this since 2014, and we will never take away the free part of this. That's part of the promise. I can't promise you that Cambridge won't go bankrupt or something, although I think it's kind of unlikely. So it's there, and it will just keep on developing.
So, if you get people from all over the world using it, have you got the resources for the computational power?
Yes, it runs on Amazon Web Services in the cloud, and basically that all scales with demand. So the response time should stay approximately the same whether you've got 100,000 submissions or 1,000 submissions a day. So it handles that potential burstiness of submissions. Yeah. We use one that we developed in my lab. It's called RASP, the Robust Accurate Statistical Parser. It's particularly good for this error spotting stuff. That's why we use it. It's actually an open source toolkit that you can download. It's a RASP, open source toolkit, which you can find on, you just type it into Google, you'll find it.
Sorry, I was thinking it's the same question. Sorry, I proved it. The invitational code, is that a web address?
Yes, that's a URL.
That's for teachers and students?
Yeah, anybody can sign up to be a teacher with this. It's effectively, what it enables you to do is publish workbooks, and you could be doing it to your friends as a learner or as a teacher to your classes. Okay, I should probably stop. I think we've overrun a bit. Thank you very much.